Welcome to Microsoft Build 2017. My name is Jianfen Lin. I'm a PM working on Windows Input Platform team. Today, I'm going to talk about the Ink Analysis API and how you can use that to enable natural pen interaction. So we have introduced Ink Canvas, and you can use that to enable a very smooth, low latency ink rendering. That brings a pen-on-paper experience to app. But what if you want to go beyond paper? Besides having a digital form of your writing, what else you can do with the pen? How about you can understand the semantic meaning behind the unstructured ink data and do smart things with it? Now here comes ink analysis. It can understand the intent behind the user's ink. Either it's text, it's document structure, list, or shapes, or drawings. And with that, you can empower the user to be more productive with your app. Now let's jump directly to a demo to show you how powerful it is. So let's run the app. So this app has an ink canvas, and I can write on it. For example, I write 2017 build, and I want to change it to build 2017. How can I do? I can put my finger down, and it groups all the ink strokes that belong to the same word. With that selected, I can drag and drop. Okay. Now to save my drawing time, let me load the file that I created previously. It's a GIF format that I saved with the ink canvas control. Let's open it. Now imagine you are building a to-do list app and you want to enable pen input because it's more natural and the user doesn't need to pull out the keyboard. And the user can create richer content. Like here, it has text and the user can annotate circle, underline, arrow, or even a frowny face. And this is getting more challenging for the system to recognize the text. But ink analysis can recognize which part is drawing and which part is text. And now I can double tap to select the line and show the recognition result. You can see that the result is correct. Now let's look at the right side. There's a phone number, and the user ran out of space. Here I couldn't show completely, but the user wrote it with an angle. And the ink analysis can look at the timestamp of each stroke and then figure out the writing direction and rotate the ink stroke before doing any kind of recognition. So if I tap on it, you can see the result is recognized correctly. And in your app, you can even put a button, a Skype call button, so that the user can start the call directly from there. And then for the outside of the circle, if I tap on it, you can see it's recognized as ellipse. Now let's look at the bottom part. There's a bullet list. I would like to share the list with my team, but my inking is not beautifully laid out. So how can I fix the layout? Since ink analysis understands that it's a list, so if I double tap on it, it shows a left align button. I can tap there, and now the layout is perfect. Now, another thing I want to do with the list is that for the second item, the writer report, I think I can do that at the end. So I want to change the order. So if I wrote the list on a physical paper, the only thing I can do is scratch out everything and then write again at the bottom. But since now it's digital, what I can do is I can select the list and drag it down, let go. Now it's perfect. And what if I want to add something at the top? Well, I can triple tap, select everything, drag it down, and add something here. Now if I triple tap again, now it's part of the list. I can even tap this button to convert to text. Instead, I can select the text and send out or paste into another app that doesn't understand ink. Last thing I want to show in this picture is the frowny face. What happens if I tap on it? Let's try. well, I got a colorful emoji. It would be great if I can replace my drawing with that emoji. Okay, the next sample I want to load is a diagram. So here, with ink analysis, I can understand the text inside and the shape outside. And with that, my app can convert those shapes into perfect shapes. I can also write some simple heuristic to detect the connection line between shapes and then convert that into a real connection between those diagram shapes that my app can understand. Now let's go back to see how I created this app. This is the XAML file. I have the in-canvas control. And underneath it, I have a canvas control where I show the converted text and shapes. Above it, I have another canvas control where I show the selection rectangle and the buttons and the candidate text. Let's look at the code. I have the namespace inking and a new namespace inking.analysis. And then I have the ink analyzer, initialize the analyzer. And this is the key part where I hook up the ink analyzer with the ink canvas. So whenever the user write a new stroke in ink canvas, that's a stroke collected event. And there, I copy the same stroke into ink analyzer. After that, I kick off an idle timer. So what I did in this app is that whenever the user hasn't written anything for 500 milliseconds, then I start the analysis. But you can customize that logic according to your scenario. You can also put a button to say, don't start the analysis until the user click on that button. So when the timer comes, I call the ink analyzer.analysis, analyze async. And that will go through all the ink strokes and create the tree structure that represent the content. With that, what I can do is whenever the user press on the ink canvas, here, I go find whether there's a word node under the user's finger. Let's go inside. It's calling ink analyzer.analysis root.find node with a kind as a ink word. And among those nodes is finding whether some of the nodes has a bounding rec that contains the touch point. If it finds a word, then it marks the word node and save it as a selected node. And then call the draw selected visual, which draws a bounding rec around the word and also shows the candidate text from the word.recognized text. If the user didn't type on any word, then it look at whether the user typed on a drawing. And then find out the drawing kind. And based on the kind, it shows the text that tells the user what kind of shape it is. So this is what I did in the press down event. And I did similar thing for the single tap and double tap and triple tap. And for double tap, I'm finding where's the line. And for triple tap, I'm finding where's the paragraph. So these are the key things of the app. The rest of the app are just showing the selection visual and then doing the drag and drop manipulation. Now let's go back to the slide. So how does ink analysis do that? There are 3 steps involved: classification, layout analysis, and recognition. First step is trying to figure out for each stroke whether it's a text or drawing. So here you can see it found a bunch of text on the left side, a text on the right side, and a bunch of drawings. After that, is doing analyzing about the document structure of the text. So it finds there are a bunch of paragraphs inside, and you can see that the bullet list is grouped into the same paragraph. After that, within each paragraph, it's finding out lines. And then for each line, it goes further. For example, here it finds a bullet, and then a bunch of words. And it does that for all the lines. With that, it finds there are 3 lines next to each other, and all of them have a bullet inside. So those 3 lines must be a bullet list. That's how it found out the list item. The last step is recognition. So for each word inside, it gives you the most confident result as the first one. And it also gives you several less confident results. You can show all of them in some kind of candidate UI so that when the first one is not correct, the user has the option to choose other candidates. So it goes through all the words like this. Today we support 58 languages. You can download the PowerPoint below the video, click the link and find out what languages they are. And you can go to the settings to install new languages. For shapes, it recognizes there's a rectangle and there are 2 ellipses. Also, there's a drawing that we don't categorize into any kind that we understand, but we mark it as an unknown drawing, not text. Today we support 14 shapes. So these are the high-level architecture of ink analysis. You can see that it's a fairly complicated process. There are lots of analysis inside, but we encapsulate everything into the engine, and for you, it will be a very simple, easy to use API. And as you can recap from the code that you just saw in Visual Studio, there are only 3 key things that you need to do in your app. First, in the stroke collected event, you pass the same stroke into Ink Analyzer. Then whenever you are ready, you call the analyze async. And inside the result, you can call the find nodes and look for the nodes that you want. You can also do the traditional tree traversal. You go from root and you go find the children and find children's children. So for this new API, we already got several big customers using it. Now let me show you the live demo. The first one is the handwriting keyboard. You can handwrite text in it, and it's calling the same handwriting recognition engine. The next one is the sticky notes. You may know that you can write the list inside. And you'll notice there's a button showing up. I can tap on the button, and it's recognized as a real list. I can press down and move the item around, or I can tap on it to mark it as finished. Now let me start another new list. So here I can write a note like this. And then Ink Analysis recognizes the text, and when the app finds the keyword tomorrow, it highlights it. I tap on it, I can add it as a reminder. Another thing I want to show is the PowerPoint. So today in PowerPoint, you can go to the Draw tab and then click the into shapes. After that, all of your drawings will be converted into PowerPoint shapes. Now let's go back to the slide. We also got some third-party companies that join as early adopters to help us with the API. The first one I want to show is SolidWorks. It's a 3D CAD software, and they use ink analysis and pen input for the user to draw shapes and convert into the cat shapes. So here's the demo video. So the user loaded a picture as a background reference. It's a rusty, broken mechanical parts, and he's trying to recreate the same thing in 3D. So he starts drawing shapes and is converted into perfect circles. After that, he's drawing the triangle around it. And here, the user draws some curves at the corner of the triangle. Here, the app did some custom code to detect that there's a curve around the corner. So the user is probably trying to make the corner around the corner. And that's what it does. Now the user is adding more shapes inside the triangle. And then the user draws a rectangle as the crank and hook up with the triangle. And then a circle for the flywheel, and draw some lines to connect them. Now all the parts are hooked up and it's working. Now the user can further extrude the model into 3D. Okay. Another partner that we have been working with is Sketchable. It's a drawing app, and they use ink analysis to do the handwriting recognition. They want to enable the user to not put down a pen, continue using the pen for both drawing and writing the title of the picture. And they use ink analysis so that the user can write at any angle and still get a good recognition. Now let me show me another example. It's something that would be interesting if you are working on the UI. So today, if you want to create a demo UI, you can go to Visual Studio Blend and drag and drop buttons there. But what if you can do that like in a real world, you do wireframing on paper? What if you can use pen to draw on the screen and have an app automatically generate XAML file for you? Now let's look at the app. So here, let me run the app. And it has a in canvas. I can like draw a text box here, and I want another text box here. And then I want the submit button here. And I click recognize. Now I got the UI there, and it's active interactive XAML control. I can save the file into the same project file. Now let's take a look. Okay, now I have the XAML layout code inside the same project. And you can see here is the Visual Studio preview of the XAML code. Now let's go back to the slide. The last demo I want to show is a future-looking demo. So our team have been working closely with Microsoft Research. We've been trying to push the ink technology forward. And this came out from their intern project. They want to explore the possibility of the input modality and what kind of input experience you can enable by leveraging ink analysis, the smart understanding, combining that with the pen and touch multimodal input. Now let's watch the video. So the user is converting between shapes and text, editing shapes, edit pictures, cut out pictures, arrange items, do a undo and redo of the timestamps of ink. Now it's a table recognition. You can edit the table further and write the text inside the table and have that recognized. Now he create a bullet list and automatically generate a checkbox. And then he can convert that list into a diagram. Okay. So here's all about the presentation. So at the end of the talk, I would like every one of you watching the video to think about what kind of scenario can you enable in your app using the ink analysis. It doesn't need to be a drawing app. It can be any kind of productivity app or any app that takes users' input, or even a casual game. I would like you to think out loud about what kind of cool scenario you can enable with it and how you can use that to differentiate your app and to make it easier for the user to complete their tasks through the natural interaction. So here you can download this slide and go find out the sample code on GitHub and API reference. And if you have any questions, feel free to email us. We have a direct email address just for this feature. You can go to the user voice website and vote for any new feature you want from our team. And there are 2 other build talks you can check out. And that's all. Thank you very much.